You guys didn't do 9-1? Oh, it was a test? Oh, okay, this is my night class then for this worksheet. Okay, so get 9-1 out then. Even easier. Let me get a blank one of those. Okay, so now you guys are going to move into, for the first time, unless you've taken trig before, you're going to move into a new system of numbers. So far, you guys have been exposed to, all through algebra, the Cartesian system. So you're in the real number system now. Everything on the x-axis is real, not imaginary, and then everything on the y-axis is real. So that's the Cartesian plane. Then the next thing that you learned about was imaginary numbers. You even learned how to plot imaginary numbers, where you would have real numbers along the x-axis, imaginary numbers along the y-axis, and that was called the complex plane. Now you're going to mix the two together, and it's going to be called the polar system. When you go to graph these numbers, instead of it looking like an x-axis and a y-axis, now it looks like an archery board that you shoot an arrow at. You have a little circle, then a little bit bigger, then a little bit bigger. Those are called concentric circles, and you're going to graph on that thing. We are now mixing x's and y's with complex numbers. Now, I can't get to the complex numbers and how they relate to what I'm teaching you until 3 sections in, but I can start talking about how to graph certain numbers here. So you're going to see on this first page, it's just a bunch of things, me trying to get you familiar with like terms and what the names are of certain things. Okay, like for instance, because you're going to see that what I'm going to try and get you to do is I'm going to try and get you to take the polar grid, which is a bunch of concentric circles. We're going to paste it right on top of the XY plane, and we're going to learn to intermingle the two. Just like I taught you to mingle radian-type answers with degree-type answers, you're going to relate what you know, x and y's, to the polar system. Now, when you go to graph these are beautiful graphs. These are graphs that you see in nature. Like when you go to graph something that's in polar form, you'll see a beautiful rose, or you'll see Archimedes spiral, or you'll just see really beautiful shapes that are commonly found in nature, unlike what you see in X and Y system. So let's start off by just seeing if I can get you to plot a point. Okay, so we're going to start right there. This is called the pole, right here. The origin has a new name. What is about this. This is the whole bottom line of the section, where you try to show that you know how to get from X and Y type information to R and theta type information. You're going to have to know how to plot it, and you're going to have to know how to move forward and backward between the systems, which will just happen by formulas. I'm going to give you the formulas for how to take an X and a Y and get into R and theta. So these are your objectives by the end of this section. I should be able to give you an X and a Y, you turn it into an R and a theta, and then plot it. I should be able to give you R and theta, and you bring it back to X and Y and know how to plot that. Whether you plot X and Y or R and theta, they should be in the same quadrant. I mean, that's your way of checking whether your work is correct or not, okay? So that's what we're headed for. First, let me get you familiar with how to plot something that's already given to you in R theta form, which is called polar form. See all these numbers down at the bottom? The first number, you know how when you're doing x's and y's, x is always first? Well, in this system, the R is always first. Whatever you see before the comma is R, and then I'm sure you recognize that that's an angle, so that would have to be the theta. They could give you the theta like this in pi form, and you're already familiar with the fact that theta could be degrees or pi form. If you're more familiar with degrees, convert it to degrees and then plot it. What you are seeing right above these examples, which we are going to plot, we're going to plot all of these on the next page, are all the formulas. Now, you're going to see, this is your last chapter, so let me give you your pep talk. You need your pep talk. You need to make this good. It's our last test before you go into the final. So if chapter 7, what killed you, because I didn't really put that many proofs on there. That's usually what kills people. If what killed you was the fact that there were so many formulas, because there were a lot in chapter 7, there's a lot here too, but I can try to show you the similarities because they're going to take a lot of these formulas that I give you in this section, and as we go to study vectors, which are related to polar coordinates, they're going to just they're going to redesign the formulas a little differently, but they're basically going to come right back to this the whole chapter. What? There's no math class, so let me just set you straight. Once you start college, you will never take an exam that's not cumulative. That's every single math class. So now you know you don't even have to ask your teachers. They're all cumulative. We don't, that's our way of knowing what you've learned in 16 weeks. And really, it is the grade that every math teacher will put the highest percentage on. Like for me, aren't I allowing you to use it for 2 grades? That's how important it is. So how can I base that on just 1 chapter? I need to know what you know cumulative. So that's the way the finals always are. Anyway, these formulas that you're seeing right here, you're going to see them using them throughout the entire chapter. And what's going to happen is just when you get the vectors, these will be phrased slightly differently, and I'm just going to keep drawing you back to how these formulas I gave you, and I wanted to show you that they're the same thing. Okay, so what these formulas are is if you're trying to get an x and you're trying to get a y, because I've asked you, hey, take the r and the theta and bring it back to your most familiar form, the xy plane. So if you want to get an x, you just go r multiplied by cosine of theta. What you're going to be doing back here when you do cosine and sine, you'll be doing chapter 6, 7, and 8, where you spin, draw the triangle, grab the numbers off the picture. That was the emphasis of the whole class. That never left. We always did that. So you're going to come right back to that when you do this part. When you build that triangle and go grab the cosine off of it, you will then multiply it by r, and that'll give you x. Same thing here. You're going to spin to theta, draw the triangle off of which you will get a fractional number, which will be the cosine and the sine, multiplied by r. You have x and y. Sometimes I'll make you go back the other way. The other way, I'll give you the x and the y, and you take it back to r squared. That'll be the easiest thing for you, because that's the Pythagorean Theorem right there, what you're seeing right here. It's just the sides of a right triangle. This, you got to know what you're doing. And this is, again, this is something that was in every single chapter so far. You know how when you're going to find a theta, you're going to be looking for theta. I'm going to give you y and x, just like you'll have it right here, otherwise you couldn't get r. So you'll go y over x, you'll get some kind of fraction, and it's going to be one of the ones you know. It'll either be square root of 2 over 2, and you'll know that the reference angle is 45. If you've learned anything over the course of this semester, if you get a reference angle, like let's say the tan is 1 right here. Do you remember that picture of the 45, 45, 90? How this was square root of 2 over 2, and so was this? So when you did tan, you would get square root of 2 over 2 over itself, and you would get a 1. So whenever you get a tan value of 1, you know that you're in a 45-degree referenced triangle. But then remember how the whole class has been about you knowing the reference angle and knowing what quadrant you're in allows you to figure out what the real theta is. So we'll practice that, a big thing. So we're always reviewing, more or less. Okay, if the tan comes out to be some other value, you'll see that it's only going to indicate either a 45-degree reference angle, a 30-degree reference angle, or a 60. The three right triangles that we keep concentrating on, and you keep concentrating on. Okay, so let's do it. First, before we get back into all that review trig, let's just spin around and plot a point. That's all I'm going to get you to do here. You're always going to do this. This will be the last thing you plot, and this will be the first thing you do. First thing you're going to do is spin. Okay, come to the next page. You can bring all these points over to the next page. So 230, that's what we're graphing here. And then I'm just going to copy them all over here. Negative 4, 2 pi over 3. Let's see, what else we got? I gave you 4 grids there, but I really only have 3 points for you to plot. Okay, so I chose these 3 examples because I wanted you to know how to plot the easiest of the cases when there's no negatives. What to do when there's a negative r, and what to do when there's a negative angle back here. So I gave you 1 of each. Those are the 3 you'll find in my math lab. All right, so let's see. So now we're going to go to 30 degrees. So look, this is all I'm doing, like I always do. You're going to spin to 30 degrees. Just roll right up there to 30 degrees. See that arm that shoots through 30 degrees? All you're going to do this number right here is move out 1 concentric circle, 2 concentric circles. That's it. Plot the point. Okay, so I spinned here first, spun there first, and then I went out 1 circle, 2 circles right there. That's it. And then you can label it if you want. Very simple. Just like plotting an X and a Y, only you're moving on a circle now. Okay, this one, I chose this so that I could teach you what you're supposed to do when they give you a negative R. So you see how on that one, let me show you on this one. So you have me doing this twice. You see how when the R was positive, this R value right here was positive, how I rolled to 30 degrees and then moved out 2 notches on that actual arm? Well, if let's say the 2 had been negative, if I had given you this. Like what I'm about to give you right now, this where the first one's negative. All you do is go like this. You pretend as though this is positive and imagine that you would move out that way, but then you trace the arm in the opposite direction. That is what a negative out here means. It means instead of hopping out so many notches on the actual arm where you just spun to, you just trace it back in the opposite direction and you plot the number on the opposite ray. These things are called rays. That's a ray because it has an endpoint and goes off into infinity. This is a ray. So just take that thing, trace it back in the opposite direction, and move on that one. So you would just go, instead of out this way too, you would go this way too. And that's what would be called negative 230. Okay, let's do it again. Now, if you want to, go put that in degrees. What would that be in degrees? 2 times 180 divided by 3. 120. Okay, so if you want to look at that way, because it's easier for you to concentrate on, imagine because you got to imagine going to 120 anyway. Okay, so let's spin to 120. This would be the actual arm at 120, but you see that I've given you a negative R value, right? So move 4 units on the opposite ray. Opposite ray just means, again, as I said in this previous example, trace it backwards. So just continue that line back, just as though you're elongating the line. You come right out here, and instead of moving out 4 notches on the original arm, you move it on the opposite arm. If you don't have enough circles, just add one yourself. You don't need to draw a whole circle. Just move out approximately the thickness that you see happening here. So this would be 1, 2, 3, and then another one would be out here. You can always elongate that thing. This is where the point would be, right there. Out 1, out 2, out 3, out 4. And that's what we call negative 4, 120. Okay, now I'm going to stop for a minute. Do you see that over to the side that I'm already forcing you to use the formulas? I want you to learn how to give me the XY equivalent of the points I'm doing now. And you see how you already know where the points are? Like that one. See how it came out in quad 1? When you go to do X and Y, it should also come out in quad 1. That's how you can kind of catch yourself, stop yourself from making a mistake. This one came out to be in quad 4. So when you turn it into X and Y, that X and Y should also be in quad 4. And just because there's circles here doesn't mean that you can't think of this. So you want to get yourself to the point where you're able to look at a picture like this and still get your head to think x and y. So it's still, these are the positive x's over here, negative x's. Positive y's, negative y's. So you can kind of approximate whether the x and the y that you're about to get is in the right quadrant, or whether you just completely are out ballpark. I mean, like, for instance, for this one. I haven't done the answers yet, right? But when I do get these answers right here, don't you think that the x should have what sign? What sign should the x value have when I finally do get it? It should be positive, right? Because when if there was a y and an x-axis here, and you're in this quadrant, quadrant 4, because this is still called quadrant 1, 2, 3, and 4, the x's over here are positive, and what kind of y value should I get when I finally do this? You should get a negative. Okay, so you can kind of check in that preliminary way whether or not you're even in the ballpark. You should get a positive x and a negative y. Okay, let's go back to A. We'll do C in a minute. And do what you're going to be doing throughout this section, converting from r and cosine of theta and r sine of theta into x. So just plug in to this formula, start memorizing these formulas so the same thing doesn't happen on the test. All right, so I'm going to put the point right here so you can look at it. So it's r, this is the theta. My r value is 2, and then it's cosine of 30. Now, if you think you're going to forget these steps, I am right now reviewing chapter 6, 7, and 8. Right now. I'm going to spin. Stop in the middle of this problem. All I've done is put the numbers where they belong. I have not calculated the answer yet. You should not have any kind of a degree-looking number or a pi-type number when you finish this answer. X's and Y's don't have degrees in them. They don't have radians in them. So therefore, to get rid of them, you're going to stop at the problem. You're going to spin to 30 degrees, draw that triangle like we have for the last 3 chapters, put the 30 degrees right here, and try to remember what I taught you about special right triangles. That if this is 30, that's 1/2. That would make the 60 up here, which would make this the long leg. Special right triangles have a hypotenuse of 1. And then you must remember that the leg that goes like this, the horizontal leg is the cosine, and the vertical leg is the sine. That was the repetitive thing that happened in chapter 6. So even if I didn't want to give you a cumulative test, how can I help it? Every single chapter has this thing in it right here. This is called the sine, the vertical piece. This is called the cosine. Okay, so now come back to the problem and continue. And you also have everything you need right here to do this problem. So it's x is equal to r, as I just wrote up here. Using my picture, the cosine of 30 is this horizontal leg. Square root of 3 over 2. 2 is the same thing as 2 over 1, just so you realize that those 2's cancel. And you are into this. See, you no longer have any kind of a theta type looking number, because now you're in the XY system where there are no angles. So that's half your answer right there. You're going to list your point as an XY point. So this is called being in the polar system, and this is called being in the rectangular system. Oops, ran out of room. Okay, so maybe you can keep writing that until you get used to it. Okay, now let's just go do the other one. Once you build the triangle, then that's a piece of cake, because you already have everything sitting there staring at you. But if you can't remember that that's the cosine and that's the sine, oh man, that's a lot, because that's from every chapter. So what happens once you learn this in chapter 6? They just keep building on it with new formulas that you're going to use it in. So that's what happens. Okay, so y, our value again. Sine is just the vertical piece, 1/2. Don't forget, 2 is the same thing as 2 over 1. Therefore, this 2 cancels with this, leaving you with 1. So your final answer at the end, just carry them back here and list them in XY point formation. So this is square root of 3 for your X, 1 for your Y. Now, do you see how both of these numbers came out positive, the X and the Y? That would be a point in quadrant 1, just like the polar point. So you could call that point 230, but if you were talking in XY language, you could call it square root of 3, 1. So you're learning to discuss a point in two different languages, the polar language and also the XY language. All right, so anyway, this is going to be the main theme throughout the whole chapter, that you know how to tie in, how to spin to a triangle, and how to use the formulas that they're giving you. Okay, let's do it again. We're going to do it at practice again right here. You already learned how to plot the point. Now let's practice on doing the formulas. All right, so in this problem, let's see, what was my R? My R was -4. So -4. Remember, this is the R. This is your theta right here. And I don't care if you put it in degree form or radian form, but sometimes my math lab wants it a certain way. So you're going to go cosine of the theta value, which we decided was 120 degrees. It definitely doesn't matter if you put it in degrees, because you're not giving me an answer in degrees or radians anyway. So if you're more comfortable with these in order to do the calculation. All right, so now it's going to be me spinning to 120 so I can get the values off the triangle. That's what you need at this point, or else you can't continue. Going to get the values from the right triangle that you're going to create. So here I go. I'm going to spin to 120. Okay, then using your knowledge of reference angles, how big is my reference angle this time if I'm going to stop after moving 120 degrees and then drop down here? What's this little angle? Okay, so put a 60 there. And then you see it's just the same theme over and over again. Across from the 60, the long leg. Across from the 30, the short leg. So this would be square root of 3 over 2. This would be the 30 would have been up here, which would make this a 1/2, but negative. All right, and then, of course, the 1 is the hypotenuse. And then don't forget that this is always the cosine, the leg that runs back and forth. Yes? Yeah, but we haven't finished yet. Okay, so that's why you can't see the positive that's about to happen, because we haven't even gotten that far yet. Okay, and then this represents the sine. In the end of the problem, when I do finish it, because I'm certainly not finished yet, because I have not finished plugging in. I was just building a picture so I could continue the problem. So when you get done with the problem, you should definitely have a positive x and a negative y, based on the quadrant that your polar point shows you. Okay, so here I go. I'm going to get a positive x. I'm going to go x. I'm continuing using the values right off this picture. -4 times my cosine. My cosine is this negative right here, and you see how that goes right back to a positive again? So you are getting a positive x just like you're supposed to when you're over here in quad 4. So this would be what? Negative times negative is positive. It's basically 4 divided by 2, 2. Okay, then come over here. Y. Do the R. Plug in the sine, which you already built the triangle that gives you cosine and sine. Sine is this piece right here. And it is positive in that, this is positive. The legs are, the legs are one sign. Your final answer is not the same sign. It comes out whatever the formula turns it into, and the R value. Okay, don't forget that's 4 over 1. So basically all you're doing right here is 4 divided by 2, 2. And then tack on that square root of 3. And yes, it is negative. Just like that. So 2 goes into 2 once. If that's the way you look at it, 2 goes into this twice. So 2 square roots of 3 with the negative in front of it. collect it together as a point. So your x coordinate was 2. There it is right there. And your y coordinate is -2 square roots of 3. So again, as we discussed, any point that's in this quadrant should have a positive x. That's what you have. And a negative y. That's what you have. And so it puts it in the same quadrant. Okay, last one on this page. Again, let's go plot. Just so the reason that it would be a good idea for you to plot first is so that you know what quadrant your answer should be in. So you can kind of use it as a check when you go to do the x and the y. Okay, so let's review. What do you do when you want to spin negatively? You just drop down, right, as opposed to going the way that I've been going for problems 1 and 2. Now let's see, what is this equal to? 45? Okay, so we're going to drop 45 degrees. You know what that looks like. So let me see, how big are these? These are 30 degrees each. So that'd be 30 and 60, so I'm going to go 30, and then halfway in between this and this, that'll be 45 because they're 30 degrees each. So right there will represent negative 45 degrees. Okay, now, can I make my point on this arm, or do I have to trace backwards and then put the point? What do you think? Right on this arm or the other one? Yeah. Put it on the opposite one? Yes? No? Maybe? How many people think I should put it right on this arm? Yes? Okay, and that's because, look at that number right there. It's that one that makes you hop backwards if it's negative, but it's not. So you're not going to trace backwards. That's only when the front number is negative. You're just going to come right out on this arm, and you're going to go 1, 2, 3. We need a couple more ringlets here. This would be the 4th circle. This will represent the 5th circle. You don't have to approximate. Don't go crazy. Okay, so I came out 1, 2 rings, 3 rings, 4 rings, 5 rings, and then I label the point. Okay, so again, when you go to do the x, y, and if you want to, you could do the picture right on here if you want to. I don't like to because it's already too jumbled up with stuff, so I like to just make a separate picture while I'm doing the x, y calculation. But you should definitely, when you get the x, now that you know where the point is, you should definitely get a positive x and a negative y, just like the last one. So that's why it's good to draw the picture first. Okay, here we go with the calculations. Okay, reviewing chapter 6, 7, and 8, how to spin. Okay, the R value, this is R, this is theta. We're going to get the XY equivalent now. Okay, so this is 5 cosine of negative pi over 4. Except I don't know what the cosine of negative pi over 4, although I think a lot of you have memorized this. This might be the one picture that you don't need a picture for, but I'm going to draw it anyway, just to remind you. Okay, let me spin. Stop the problem and spin. Okay, I'm going to spin down here just like I spun 45 degrees. I'm going to close up that triangle. I just spun this way, 45 degrees. You know the little reference angle is never negative, even if you spun in a negative fashion to get there. That little reference angle is never negative. Okay, so then that would make this, as all 45-degree triangles are, square root of 2 over 2, square root of 2 over 2. Now let me see, should one of these be negative? Okay, the sine or the cosine should be negative? Sine, because we're remembering that this guy that runs straight up and down is the sine. I'm going to circle that because it's crunched in there. That cosine is positive, though. All right, let's continue now. Now that I have a picture that reminds me, and if you don't draw this picture, you know, that's fine. I know some of you have this one memorized. I wouldn't mess around with the 30-60. If I was you, just to help you concentrate, I would draw it. All right, so cosine is the piece, the horizontal leg on the triangle. And there you go. You got a positive x value. It's got a radical. It's a fraction. And now we're going to do this one. So now it's r. This one should come out negative. The sign off of this picture is negative 2, square root of 2 over 2. So you basically get this same answer, but with a negative. Okay, now what would you like to stop me on and ask me questions? Please ask if you don't understand something. You mean this point right here, this part? I don't care. You can just do the point if you want. Triangle. Well, I'm thinking at this point, since the class is already almost over, that a lot of you have gotten to the point where you have memorized it. So I'm cool with that. I'm fine with that. But I at least want to see, let's come to an agreement here that showing work will at least consist of this, that you at least show me this. If you don't need a picture to do that anymore, good for you. That means you've made progress. You should be at that point by now. So that's fine. But just at least, can you please give me at least this right here? Start off the formula for me, and then at least give me this, where you jump to the next step, and you can leave the picture out if you want to. Okay? No calculators. That means you don't know anything. You can't do it, and that's why you touched your calculator. Okay, that was just an extra grid right there. Come over here. Okay, a little creative thinking. You got to think about, again, we're going to review chapter 6 here. One time I taught you about these things called coterminal points, where you plot a point and then you try to land on it again, but when you spin around to land on it again, it now has a new name, but it's the same point. You're doing that right now. Okay, we're going to practice coterminalism. Okay, so let's see. And you can't when you're trying to give me 3 other points, you got to do the original one first. Okay, so if I was going to 3, 140, that means I would come right here. I would move 140 degrees. And I think you better think about this right here, that if you went 140, how much is this little angle squeezed right up in there? That would be 40, right? Because we're going to, so that you can give me some of the answers, I'm going to want you to think about vertical angles. But let's do the ones that are most obvious to you right now. Let's say, okay, now let's see what we're doing. We went to 140. That's this ray right here. You don't need to draw notch marks to represent the circles. And we're going to go 3 units out on this arm that represents 140. So we're going to go out 1 notch, out 2 notches, out 3 notches. So look where your point is. Right here in quad 2. This is 3, 140. Therefore, every answer that you give me should be in quadrant 2. Now, you can name this point in many ways, infinite ways. Maybe one of the most obvious things to you is, hey, why don't I spin around an extra 360? Bam, I'm right there again. Doesn't that always get you if you just keep going in multiples of 360? But now that I taught you some other things today, you might want to be a little bit more creative than continually just spinning around 360 and hitting the point again. So this is the most obvious answer. This one you just add 360 to where you are presently standing. To where you are originally. Okay, so let's see. I could keep this a 3. And then I could, what could I call the back number if I'm just adding 360 and changing? That's the only thing I'm really changing, right? So it would be 60 added onto 140 would be 200, and then another 500. Okay, so that's what I'm doing. I'm just doing the 140. I guess I'll write it right here. I went 140, added a full revolution to that, and that put me at 500. So there you go. There's one of your answers. It said give 3 additional answers. So this is one of them. What's another thing I could do? Now you're probably milling some other possibilities in your head at this point. What's another way I could land right smack dab on that point that I originally drew? Yes, that's one. That's the most hardest one to think about. What were you going to say? Go negative. That's the next most obvious one, and then that one that you said. So both of them just gave me different answers. He said we could spin negatively. If we spun negatively, this would be 180 and then an extra 240 to get right there. I mean, an extra 40. So how much would that be altogether if I went 180 to get to here and then an extra 40? Negative 220. Okay, so this could be called a traveling of negative 220. So here's another answer. Negative 220. I think these are easiest to give in degrees because, you know, the reference angles aren't things that we're familiar with. And then once I got to negative 220, if I want to land on this particular arm, don't I have to go out positive 3? So I'll keep the 3 positive. Then if we want to go with your suggestion where you were saying to use like a negative 3, then let's see. We're going to use the negative 3. So let's see. We would have to go negative 40. Does everybody see that if I went negative 40, I'd be lined up with this ray right here? So once I get that negative 40 ray, instead of jumping out on the negative 40 ray, I could hop backwards by using a negative value. So let's say, and if you don't remember this from geometry, those are called vertical angles. Vertical angles are always equal. They look like a little bow tie. So you got a little bow tie right in here. Okay, right in there. Those are the two pieces of the bow tie. Those are called vertical angles. They're equal. So I rotated to negative 40. But then instead of going 3 notches out on this negative 40 arm, I hop backwards. This is what makes you hop backwards. So you end up right on the same point 3 different times, 3 different answers. Okay, that's enough of that. Let's go to where, what was the third one? Oh, sorry, I didn't show it to you. Negative 40. I didn't have it high enough. Negative 3. Yeah, there's a lot. There's infinite possibilities. These are just like the most. These were the one. These would be the ones that I would get from almost everybody in the class. Not as many people would be able to come up with this one. This is the second easiest one. That one's the easiest one of all. But there are many, many, many answers. So I'm not going to do this one, but if I was going to do this one, well, I guess I should. I should probably do this one because this one requires more work. Because the reason we were able to do this one so easily is that they gave us the r and the theta. But when you have negative 1, 1, you don't know the r and the theta, but you get it yourself. So why don't we practice that because that's what the whole next page is about. Okay, so let's do the second one. Okay, so they gave us in part B, this was part A. So in part B, they gave us negative 1, 1. Right now we're looking at an x and a y. I know that because there's no theta here. I want to get an r and a theta, and you were given formulas on the first page. On the first page it says if you want an r, do the Pythagorean Theorem as though you were in a triangle. Leg squared plus leg squared equals r squared. That's the hypotenuse. So it's Pythagorean Theorem. Okay, so right now I'm going to get r. So let's see, x squared plus y squared, negative 1 squared. There's my y squared. I'm getting them from right here. This is equal to 1 plus 1 because anything squared is positive. This is equal to 2. If I want to get r, I take the square root of this as well as this. So r is square root of 2. So moving over, getting myself to the point where I was when I started this problem. I started with an r and a theta, and I'm trying to get myself there for this other problem. Okay, so this is r, square root of 2, and then my theta. Now when you do the theta, you have to have understood, very specifically what I just did on the last 3 problems. How to spin, how to talk about a reference angle, and then how to talk about the real theta. So I think, you should look at this formula that I gave you on page 1, and maybe you want to fine-tune it a little bit. You know what this angle really has you finding? The reference angle. So maybe you want to put that first, because you can't ever get to this guy, the big theta, the real theta, unless you find the reference angle first. The reference angle always comes before the theta. So why don't you put that right there, so you know that that's all you're really finding when you use tan of theta. Okay, let's go back to what we're doing right now. And take that formula and continue. Okay, so here I am. I'm going to do tan of the reference angle. I'm going to get it by doing y over x. I'm just going to keep writing the formulas for you in hopes that, it helps you memorize them. So this is going to be equal to, let's see, 1 over -1, which is just -1. So I want you to do part of this in your head. Again, we've talked about this a lot, but let's think about it. Forget the fact that there's a negative there. When is the only time that you get a 1, any kind of a 1, whether it be negative or positive, for tangent? 45. Okay, we already know the reference angle. Come down here out of this tangled mess and just write reference angle is 45 degrees. Then you're going to see what we're going to do with it. All right, so we know it has to be 45 degrees. If you want to do it in radians, you can do it in radians. Okay, so here's what we keep going over in these chapters. I might as well review. It's on the final a lot. You are going to make sure that you draw a picture with a reference angle of 45 degrees. But what would it be nice to know before you go trying to draw your reference angle inside of a triangle? Wouldn't it be nice to know what quadrant to do it in? Okay, so you always have to be thinking about that. Well, what information do you think you're eyeballing right now that tells you what quadrant you're in? The -1, 1. Doesn't this tell you exactly what quadrant you're in? And haven't I said that whether you're doing r and theta or whether you're doing x and y, that those 2 points are in the same quadrant? So if this is in quadrant, what quadrant's that in? If it's in quadrant 2, then this r theta that you're struggling to get is also in quadrant 2. So in essence, you really do know where you're at. You're in quad 2. So when I say draw that reference angle, I don't mean anywhere you want. I mean go and draw your triangle in the quad you're supposed to be in, quad 2. Which again was told by this story right here. Put the 45-degree reference angle. You already know that the tan is what it's supposed to be. The tan is -1 in that quadrant, which you can prove to yourself. Both of the legs are square root of 2 over 2. Not that you have to do this, but this one would be negative, that one would be positive when you're in a 45 degrees. So do you see that the tan, like it says right here, that it was supposed to be -1? It is -1. This over this is -1. So not that you have to do that in the middle of the problem, but anyway, this is really what I wanted you to get by drawing that picture, the real theta. What is the real theta based on where this is? This always tells you where the real theta is. How many you can tell me how many degrees that is that hypotenuse spun to? 135, right? Because if this whole thing is 180, but you never made it to 180, you made it here and then stopped 45 degrees before you got to 180. So you have to shave off the 45 from 180. That is the repeating, that's another repeating thing from all 3 chapters. This has to be 135. And I'm going to keep saying this until you take that final. Every time you try to mix a reference angle with the real theta, one second, the reference angle with the real theta, you're either adding or subtracting. Every single blessed time. You're adding or subtracting. If you're over here in quad 2 or 3, here or here, because you know in this quadrant, What is the relationship? Let's see how many of these things you can answer off your head. You should be getting to this point by now or pushing yourself to do so. What's the relationship between reference angle and theta when you're in quad 1 and only quad 1? They are what? They're equal. But every single time you're in any quad other than quad 1, you're either adding or subtracting the reference angle and either 180 or 360. What are you closest to when you draw a triangle over here? Are you closer to 180 or closer to 360? You're right by the 180 mark, right? So anything you do over here is going to have to do with either adding or subtracting to 180. What do you add or subtract to 180? The reference angle. You take a landmark and you either add or subtract the reference angle, the landmark that you're closest to. We are closest to the 180 landmark. If you stop before you get to that landmark, it's always subtraction. If you roll beyond the landmark, then it's addition. It will only ever be addition or subtraction. If this picture was over here, then you would either add or subtract to 360. You've got to think about the landmark that you are closest to. Now, I went beyond that and tried to get you to do it with fractions because it's important to do that. But what's your question? No, not for me. You know, the only one that's bossy is my math lab. They want it a certain way. They want it a certain way. All right, so 135, we're good there. And if you, I'm going to give this for those of you that are trying to practice, as you should be, how to give the answer both ways. If you did want to give this in pi form, then you got to think like this. This is pi over 4, right? Yes, this is called 180. So true. But it is also called 1 pi. And when you're talking force, that is a full 4 force. So if you were going to spin around this thing and you were trying to talk in pi language instead of degree language, you would say, okay, I'm almost at the landmark called 4 force pi, 4 force pi. I stopped 1/4 before I got there. So 4 force minus 1/4. Whenever you're in quadrant 2, you're subtracting from the landmark. And you're subtracting the reference angle. Whenever you're down here, you're adding the reference angle to the landmark. Yeah, for me, I will be ecstatic if you give either one. Yeah. Most people like to give it in degrees, but, you know, whatever. This and this are the same exact answer, that and that. All right, let's roll on. Now, wait, what else were they asking us here? Oh, anyway, I did this one because you're doing this thing right here on the whole next page. But the question really was this. Give me some other names for this thing. So remember when I was just having you come up with all these alternative names where you could just add 360 and give an answer, or you could spin backwards and give an answer, or you could hop backwards with the negative if you want to. So let's try and force our head to do this because I know these problems appeared in my math lab. Okay, if you're going to do the hopping backwards thing, you're going to have to realize that if that's 45, this is 45. Okay, so let's just try and give another answer here. I'm going to do it off the degrees. Okay, let's give 3 other answers for this. Square root of 2 over 135. Okay, another answer to that would be, that means equivalent when you have 3 lines like that. Okay, so we could keep this the same and then just add 360 to that, which would be 400, let's see, 400 and what? Yeah. All right, so that's one answer. Or we could do the one that was you offered me, where I could spin backwards and then stay on the same, I could stay on the same arm, and then I could also do the negative r. Okay, so let's spin back. Let's spin negatively. Okay, remember, we want to land right here. We've got to land over here. And by the way, let me show you this. This original angle, look where it is. Let's see, what quadrant is this in? Square root of 2, 135. All right, where is this answer? Oh, yeah. See, what we did so far was to give us the r and the theta. I think you better clean up this picture by giving yourself a nice clean picture before you go and do this. Write your original r and theta, because this will help you get all these answers right here. Otherwise, all right, so square root of 2, 135. Let me see, square root of, what am I doing? 135 would be over here. So, yeah, I don't know if you want to give yourself a new picture. But anyway, this is where 135 is. And let's just say that's called square root of 2. I mean, you could do it off the original picture if you want. Oops, lost my white out. Ignore that arm. Okay, so everything you give me better be in quadrant 2, but you could do it off this picture if you want to. Okay, so if I was going to spin backwards, I would have to go like this. I'd have to go 180 and then how much more? An extra 45. So 180 plus 45 would be 225, and I'm spinning negatively. Okay, so I'm going to go angle in the back, negative 225, and then I'm going to keep the r the same so that I'm hopping out on this arm right here, or you could do it here. You're going negative 225, and you're hopping out the same thing. One more answer, the one where we make it negative. Where would I have to spin to and then hop backwards to make that happen? Okay, so 45 degrees, negative 45 degrees, and then hop backwards. So that would be my third answer. Those are kind of hard to think about. Well, the last one might be. I don't know if the other two are. All right, go to the next page. Okay, so polar coordinates are given. You can see you got a theta here, so you know what language you're in. You're in r theta right now, and you're going to go and give the rectangular coordinates. I gave you because I wanted to review with you, hey, what does the picture look like when you really can't draw a triangle? So this is one of those from Chapter 6, quadrantal angles. I will not be able to draw a triangle, but I'll still have a cosine and a sine. So I wanted to remind you right now, if I was to spin to pi over 2, how many degrees is pi over 2? 90. So I'm going to be right here. And do you see it says go out 3 notches? 1, 2, 3. So let's say this represents 3 pi over 2. So let me remind you from Chapter 6, whenever you land right on an axis rather than in midair like this, see my rotating arm landed right here, lined up with the y-axis rather than here or here or here or here. So you can't draw a triangle. When this happens, everything's about zeros and ones. What you have to think about, see yourself, and you have to envision that where you are right now is inside of a circle with radius 1. So what are the numbers right up here for x and y? 0, 1. All right, now, I know you're going to think this is strange. I would do this problem. Didn't I give you formulas where you calculate the x and you calculate the y? I could go plug into those formulas, but you're going to get 0 and 1 for your answers, because when you land right on an axis, you really don't have to use the formulas. You could just go with the zeros and the ones that happen there. So if you must, I wish you wouldn't though. If you really need to, you could do this. You could go, oh, I wanted to get x, even though we already have it. I'm just telling you to get out of some work here. And you could go r times cosine of theta. That was the formula that we just used in the previous problem. But what's the point? The radius here is 1. You'd be doing cos times cosine of pi over 2. And if you remember, this is the cosine, and this is the sine. So when you get done doing all this work, the cosine would be the x value, and you would end up getting 0. Well, you already knew that. You already knew that the x value is 0. See it right there? And you already know that the y value is 1. So what I'm telling you is if you land on an axis, you are going to be able to get out of a ton of work. Okay? You don't really have to plug into the x and y. Your answers will be 0s and 1s or 0s and negative 1s, that sort of thing. Okay, same thing here. Let's go to this. I'm reviewing heavily Chapter 6, 7, and 8 by doing these problems. This is very related to those chapters. 0, 3. Let me see. Yeah, because of the r value. Oh, what did I put in there? I put a 1 in for r, didn't I? Oh, I messed it up. Okay, sorry. Backtrack. You are going to have to do this. Okay, so what was I going to do? Let me show you that this should have been a 3. Please fix that. But then what do you get? What do you get for that value? 0? Yeah. Okay, so then let's see if the y turns out to be different. You just pointed something out. Okay, let's see what happens here. So anyway, the r is 3, and the sine value is 1. Yeah, you got to do it. Because if I give you different r values, that's going to change it. So 3 times 1, there's my sine value right there. Don't forget, when you can't draw a triangle, and you know, when you draw the triangle, aren't the x's and y's the legs on the triangle? You got an x here and a y here. But when you can't draw a triangle, it's just the x and the y coordinate. So yeah, use the formula even for those. So this will be 3. And then here's your final answer, 0, 3. Sorry, I messed that up. But a pretty easy save. Okay, let's do this one. This one you are going to be able to draw a triangle. Okay, as long as you don't land on an axis. Okay, so let's spin to 135. We just did this one. You spin to 135. That makes this how much? How much would that be if you spin to 135? 45. Good. It's just 180 minus 135, and that's where you get that. You're going this landmark minus how far you spun to get that. Okay, if that's 45, this is square root of 2 over 2. This is square root of 2 over 2. But this one is positive, and this one's negative. Okay, so here's the formulas. R cosine theta. So what was the R? 9? This is the R, this is the theta. The cosine you now get off the picture. So you know that first page that I did where I did 3 of these? I'm doing the same thing now. And then the cosine, you get it right off of the picture of the triangle. Okay, so cosine is this piece. The sine is the piece that runs up and down, so it's negative. Square root of 2 over 2. Don't forget this is 9 over 1, and when you're multiplying fractions, it's top times top, bottom times bottom, and then you reduce those coefficients if you can. Okay, y, formula is r, but sine of theta. So it's going to be the same thing, just positive, because the sine is the positive square root of 2 over 2. So it'll look just like that. All right, now this is starting to get super repetitive, so what I'm going to do is I do want to do this one. I want to do 1 or 2 of these, but since I've already done 2 of each of these, remember how on the last page where I had a -1 and a 1, and I converted it to an r and a theta? That's what that is. That's more of the same thing right there. I'm probably going to have to pick up with this right here. Yeah, so that's what I'll pick up with for you. Let me do this last one. All right, so one more. All right, so right now it's x and y. There's no theta here. I'm going to get the r squared value first, which is this formula, x squared plus y squared. Pythagorean Theorem, you're squaring the legs off of a right triangle. So it would be -9, +9. This would be 81 plus 81, 162. So you're right here. You want the r, so you're going to go square root. R has to be positive, so none of that plus or minus stuff. Break this down. Try to retrieve the square root. Well, 2 times 81 was that, so you can break it down like that. 2 times 81, where you can actually take the square root of that to simplify it a little further, but leave the 2 underneath. So you bring the 81 out from underneath the square root as a 9, but leave the 2 up underneath it. So you're simplifying that square root of 162. Okay, so this is what your r value is. You took square root, you got r. Square root of this in simplified form is 9 square roots of 2. So I have my r value now, and I just need my theta. Okay, so here's the theta part. Do the reference angle first. This is just like that other problem that I did where I had a -1 and a 1. Let's see. Do you see that I'm getting the same thing? It's 9 on the top and -9 on the bottom based on the values they gave me. See, they gave me 2 values that were the same. Therefore, once again, here I am looking at a tan value of 1. Therefore, the reference angle has to be 45 degrees. But now make this happen. What quadrant should I spin in to get to the real theta?